Hello everyone, my name is Wang Nan. I'm a PhD student of Wuhan University. The topic of my presentation is monitoring large-scale hydraulic engineering using Sentinel-1 INSA, a case study of China's south-to-north water diversion middle route project. My presentation will include the following aspects. The middle route of a south-to-north water diversion project is one of China's greatest hydraulic projects. Uninterrupted water supply is significant to the water receiving areas. It is essential to conduct continuous deformation monitoring for the MRP. The surface monitoring measures of MRP mainly include leveling, GNSS, and sensors. But these ground-based tools have limitations. By contrast, the satellite INSA is more suitable for monitoring large-scale infrastructures. The work of applying INSA to monitor the canals consists of over deformation survey and fine monitoring of key sections. The unstable canal sections were identified and the geological conditions and the structural designs were combined to analyze the key sections. Our study area is the MRP canal within Henan province, with a total length of 730 kilometers. It passes through areas with poor geological conditions, such as swelling soil areas and coal mining areas. In addition, some of the open canals contain filled or excavated embankments. We used 309 scenes of Sentinel-1 AW mode images. According to our results, most of the canal within Henan province is stable, except for some canal sections. From the large-scale deformation rate map, we identified 20 deformed canal sections and 7 suspected deformed canal sections. Most deformation of canal sections is caused by surrounding ground subsidence, such as the canal section in Zhengzhou area. It passes through areas with positive deformation and negative deformation alternately. The deformation of canal sections in Jiaozuo is also accompanied by surrounding subsidence, whereas some are deformation of the canal slope itself, such as the canal in Nanyang. In the key canal sections fine monitoring, we focus on 2 sections. The first is Shahe Aqueduct. It is overall stable, except for the entrance of Shahe Beam Aqueduct and the turning of Lushanpo Landing Aqueduct. The deformation of A is related to the soft sandy soil on the bank of Shahe River. The stability of B is affected by the surrounding deformation. The other one is Yuzhou Changge Canal. The settlement canal is 2.5 kilometers long, and the maximum deformation velocity is near -20 mm per year, and a more serious settlement funnel caused by coal mining activities was found at the place about 2 kilometers from the canal. We conducted validation of our results with leveling data. Their correlation is 0.95, and the RMSE of their differences is 2.41 mm per year. These are conclusions. Thanks for your attention.